Good morning, grade 12 maths learners. Today I want to define what a tangent is. A tangent is a line which touches a curve at a point of contact. If it is a line, then it means the equation y minus y1 is equal to m bracket x minus x1 must be used when calculating the equation of the tangent. And I need you also to remember that the gradient is given by y2 minus y1 over x2 minus x1. And we also know y is equal to mx plus c, which is the same as the one that I gave you initially. Now, it is important also to notice that when y is equal to k, then this is a vertical line. It is parallel to the y-axis. And x equal to k is a horizontal line, which means it's also parallel to the x-axis. That is very important. Now, to navigate through this lesson, I want to use an example so that you can understand how we can find the equation of a tangent. The question that I have says, consider f of x, which is equal to minus x squared plus 2x plus 3, and the lines y is equal to minus 4x plus 11, y equal to minus 3x plus 9, and y equal to minus x plus 5. These equations are sketched below, so please look at this diagram. I tried to color code in order for you to see distinctly the line that we will be discussing. If you look at the quadratic curve f of x, it is this graph which is black in color and is the only curve we have in this diagram. Now we have lines y is equal to minus 4x plus 11. It is the yellow graph, which is a straight line, and it passes through B as well as A, and also passing through the point 11 on the y-axis. And if you look at y equal to minus 3x plus 9, it is the red graph. And you can see it's passing through D, A, and a point 9 on the y-axis. And the last one, which is y is equal to minus x plus 5, is the purple one, which is passing through the point A as well as C, and also passing through the point 5 on the y-axis. You can be required to find the gradient of any of these lines. That is what we already know. It will be change in y over change in x. Like in this case, we had the yellow graph having a gradient of 4, or rather a minus 4, because it is minus 5 minus 3 over 4 minus 2, which gives us minus 8 over 2, which becomes minus 4. Very, very important. All these lines are not tangent because you can see they are crossing the curve at 2 points. So they are not tangents. A tangent is a line that only touches a curve at 1 point on the curve. So all these three are not tangents. Now I want us now to look at introducing an h to our study. Now we assuming coordinates of b are not known. You see from here our coordinates of b are 4 and -5. Now we are saying the coordinates of b are not known. So how do we determine these coordinates of b? Now from what I have here, I said assuming coordinates of b are not known and are given by b is equal to 2 plus h and f of x of 2 plus h, these are the new coordinates of b. Therefore, to find the gradient of AB, we have f of 2 plus h minus f of 2, which happens to be what I have here. When I substitute 2 plus h into our function, I end up with that, which is substituted, and we subtract the 3, which is f of 2, and we end up with a minus h minus 2. However, as h goes to 0, what we are saying is when h is 0, it means we are at a point b which is 2 and f of 2. In other words, these 2 points coincide, which means it's now a tangent because it's no longer cutting the graph at 2 points. So as our h goes to 0, we have a limit given by gradient of the tangent will be equal to limit of minus h minus 2 as h goes to 0, which gives us a minus 2. Our work today will be the classwork. The whole of exercise 2 will be done today, and you'll do that later. Thank you.